In this segment, we'll talk about some of the prior knowledge that you'll need for learning how to do regression. And one of the ones is partial derivative review. Let's go ahead and do that. So if you remember, your ordinary derivative is defined as this, that we find the slope of the function at a particular point, and we take the limit of the run to 0, and that's how we get the ordinary derivative. Now the partial derivative now means that, hey, you may have a function of more than one variable. So this is only for a function of one variable. So now if you have a function which is a function of two or three or four or five variables, more than one, then you can define something called a partial derivative. So if you take the partial derivative to x, let's suppose, then you are doing very similar things to what you are doing here. Let's suppose you are changing just the value of x so far as the difference, finding the difference between the functions is concerned, the rise part, but you keep the y constant and you divide by delta x. That's del f by del x. And del f by del y is the same thing. You keep the x constant, but you change the value of y, and that's how you find the difference between the two function values. That's the rise part, and this is your run, and that gives us the partial respect to y. We do need to understand these constants for regression, because many times we'll have, most times, so we'll have the model which will have more than one variable, and hence in order to be able to develop regression models, we will need to know what partial derivatives mean and how they are to be found. Let's go and take an example. So here is a function given to us, which is a function of x and y, and we're asked to find just the partial derivative to x and y. Let's go and do del f by del x first, and then we'll do del f by del y. So in part A, we had the function which was given to us, which was 2x cubed y squared plus 7x squared y squared. We need to take the derivative of the function with respect to x, so we will take the derivative of 2x cubed y squared plus 7x squared y squared here. And what we will do is we have to treat everything other than x to be varying. That means 2 and y, in spite of y being a variable, we have to consider it to be a constant. So we can take 2y squared outside and do del by del x of x cubed. And then we'll take 7y squared outside and do del by del x of x squared here. So that's the way it's going to be. So it'll be 2y squared. The derivative of x cubed is simply 3x squared. And then you have 7y squared, and the derivative of x squared here is 2x. So the value turns out to be 6 x squared y squared plus 14 xy squared. So that's del f by del x. Let's go and see what we get for del f by del y. So our function is 2x cubed y squared plus 7x squared y squared, and now we're supposed to find del f by del y. So we'll take the partial derivative of y for this function which is given to us, and we're going to now treat anything which is other than y to be a constant. So 2 will be treated as a constant, x cubed will be treated as a constant, but not y. So what we'll do is, let's go and first break this down to this. And then what we're going to do is we're going to take 2x cubed outside, because that's to be treated like a constant. This will be del by del y of y squared. Then 7x squared has to be taken outside. It will be del by del y of y squared here. So I'll get 2x cubed times 2y plus 7x squared times 2y, and that gives us 4x cubed y plus 14 x squared y. So that's the value of the derivative of the function with respect to y. As I mentioned to you, in our regression analysis, we will need to find partial derivatives in order to develop our regression models which have more than one variable. Hence, that's why this prior knowledge is important. And that is the end of this segment.